No.
Here you go.
Yes.
There, add people something. Add people.
Okay.
Their copy link will come.
Nothing.
That is,
Here, this link I can copy, right?
no, I know, sir. Don't do that. Like using that, they may not be able to join. Can you undo this?
Okay.
Here you go, sir. This one. Messages are
Where? Here.
this one. Chart. On this one, you go meeting rules or something.
Host controls.
No, not there. Meeting tools like here, sir. This.
Okay.
There also. Yeah. Then open this one. Sir.
This one. Okay.
More option. Adjust record. Click on this side.
Okay. Nothing.
Normally, I do in phone, sir. You
I will copy this only.
no, sir. Like
It will not go. No?
you have Akash Guru with you.
Yes, sir. Here.
Open that Akash Guru.
Hmm.
Join lecture.
I already joined.
It will come like this, sir. You see, there's no that shape. You have Google Calendar with you, sir.
Hmm.
Upload this. Open Google Calendar. Here in apps or something. Open new tab.
Okay.
Google Calendar. There in this calendar.
Calendar, yes.
There, this class will be there. Oh, loading. Sir, it came, sir.
Hmm.
Can you minimize this? Today, it is not showing yet, sir. I think this is not your official account.
This
Here,
one.
you right click, sir.
Yes.
Copy is not coming as well.
Here.
Here, copy. Now, WhatsApp, sir. Second class link also is fine, sir.
In this SR01,
Yes, sir.
right? This one. Yes, sir. Yes, sir. In SW also I need to post, huh? SW01 also I posted. Right. Alright. Now tell me whether the screen is visible to you all properly or not.
Yes, sir.
I need to switch on speaker somewhere. I'm getting. This one, I think. Admit. 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 Array, can't we keep any option like admit all? Whoever queues joins, it can be admitted. Is there any such option? No. But it is not allowing, man. Every time I need to admit separately.
Sir, there is an option, sir. Then you'll have to change it in the owner settings, sir.
Where?
Meeting host. If you make the link open to all, then anyone can join anytime, sir.
Okay. For example, okay, host must join before anyone knows. Oh, no, meeting access type. Restricted, trusted. People can join without asking if they belong to your organization or invited using their Google account. Attendance tracking. Then now I think they can join. It is open to everyone now. Right. Right, sir. Listen, sir. Yesterday we have discussed about alcohol phenols ethers. Means alcohol's part is over. We need to start phenols and then we need to go for ethers topic. Now, regarding phenols, first we will go to preparation of phenols. They have given classification of phenols. So first I will start from classification. Then preparation from aniline, benzene sulfonic acid, salicylic acid, halobenzene, cumene. Okay, physical properties. Right. Now I will open the library here also. Alcohol phenols either student content, and this is Invictus. Yes, sir. Now see this, sir. Please, please, please. Right. So first we are discussing about nomenclature of phenols. Phenol is also called as carbolic acid. What is carbinol? Methanol is also called as wood spirit, or it is also called as carbinol. What is carbonic acid? How I can admit? Again, it is getting messages. Okay. I have to keep open to all. Huh? I kept open to all. Now I think so. They will. Anyone can join. Okay, right, sir. Now coming to this. This is phenol. If we have two OH groups, please. What we call it as? What about this one? Yes, sir. And what about this one? And what is this one? What about this one? And what about this one? We know this one, catechol. Oh, sorry. Catechol. This is called resorcinol. This is phenol. This is pyrogallol. This is hydroxyquinol. This is fluoroglycinol. Right? Or see corresponding spellings also, man. PHLORO. Fluoroglycinol is okay. Hydroxyquinol is okay. Pyrogallol. Okay, RO. Pyrogallol. Quinol is okay. Quinol is also called as hydroquinone. This is also called as hydroquinone. Then resorcinol, catechol. Okay, carbinol, phenol. What about this one? What is this one and what about this one? Naphthalene OH group, naphthol. We call this position as alpha position. So we call it as alpha naphthol. This is called beta naphthol. Right? Now, while you are giving numbering to naphthalene, I have to give numbering like this, right? This is 1, 2, 3, 4, 5, 6, 7, 8. Then at the end, we have to give numbering to fused carbons. Correct? Huh? And we call these positions. These 4 positions are named as alpha positions. And these positions are called as beta positions. Alpha, alpha, 4 alphas, 4 betas. Right? How many resonating forms are there for naphthalene? 3 resonating forms. Any special thing we discussed about pyrogallol? It absorbs oxygen. That reaction also, if you remember, we discussed that reaction also. Where we have discussed means gas ideometry. Just a moment, I will open that also. We discussed gas ideometry in states of matter chapter. So let me write that here. It absorbs oxygen. That's why it is used as reagent in order to quantitatively analyze amount of unreacted oxygen. Right? is not present here. I think so. This is different one. Chloroglycinol not there. I will show you. So I might have written it somewhere. So from there I will copy that and later I will discuss that part. Right. Now coming to preparation of phenols, sir. In which first one from aniline. Preparation of phenols from aniline. You respond, sir, how we will prepare phenol from aniline? Hmm? Oh.
I can call and tell him.
Oh, yes, sir, you can call. How aniline is prepared? How phenol is obtained from aniline? Right, sir? Primary amines allowed to react with NaNO2 in terms of HCl or HNO2 forms diazonium salts. Diazonium compounds will water forms phenols. If it is benzene, you will get phenol, right? If it is H3PO2 or ethyl alcohol, you will get benzene, right? So let me take that reaction. So I am taking primary amine allowed to react with NaNO2 in presence of HCl or NaNO2 in presence of H2SO4 at a temperature of 0 to 5 degrees centigrade. Temperature should be less. Otherwise, what happens? N2 gas will escape. Then it will convert into benzene. Right? To make diazonium compound stable, temperature must be low temperature. If it is aliphatic, they readily form alcohols directly. No need to add any other reagent. Directly they will form alcohols. Aliphatic diazonium compounds are unstable. Aromatic diazonium salts are stable up to 5 degrees centigrade. Beyond 5 degrees centigrade, again they are unstable. Right. Now what you will get? Benzene diazonium compound N triple bond N plus, and what you will have? If I take HCl, I will write Cl minus. I am taking H2SO4, I will write HSO4 minus. Cation is there, anion is there. That's why I call it as salt, diazonium salt, benzene diazonium salt. I don't call it as benzene diazonium chloride. I will call it as benzene diazonium bisulfate, right? Or hydrogen sulfate. Benzene diazonium hydrogen sulfate. Now, this is allowed to react with water on heating 80 degrees centigrade. Now the product will be N2 gas goes out, water will donate lone pair of electrons, it will form phenol, and one H plus goes to HSO4 to form. So product will be phenol plus N2 plus H2SO4. Any questions are in this preparation of phenol from aniline? Next. From benzene sulfonic acid, second reaction. From benzene sulfonic acid. Benzene sulfonic acid means you will have SO3H over benzene, right? If you have SO3H over benzene, it is highly unstable, right? So if you add water and boil, it will be replaced. Or if you add NaOH, then also it will be replaced, right? So corresponding reaction. benzene sulfonic acid. I am taking SO3H, allowed to react with NaOH on heating. Can I call it as a fusion? Because I am providing high temperature. That's why we are calling it as. It is not getting projected. Huh? Right. So on fusion, as we are providing high temperature, because we call it as a fusion. So what you will get? SO3H will be replaced by OH. But as we are providing basic medium, obtained phenol will react with another mole of NaOH to form phenoxide ion. So product will be O minus Na plus. Correct, sir? Plus it will convert into Na2SO3 plus H2O. Now, if it is allowed to react with any acid in presence of H3O plus, then it will convert into phenol. H plus will be restored. So we are adding H2SO4. Then this will convert into phenol. And this converts into sodium bisulfate. So preparation of phenol from benzene sulfonic acid. Next from salicylic acid, third reaction. From salicylic acid. See this one? On benzene, if you have OCH3 group, what we call it as? Anisole. Methoxybenzene, we also call it as anisole. If it is OC2H5 on benzene, then it is called as OCH2CH3, ethoxy. Then it is called?
Sir.
Yes, sir.
Sir, are you writing, sir?
Yes, sir.
Sir, we are not able to see it on the screen, sir.
Oh, 1 minute, 1 minute. I'm sharing. I will stop sharing. I am resharing it. Continue. Start. Now, sir?
Now it is visible, sir.
Right. So on benzene, if you have OC2H5, then it is called phenol. Correct? Let me check the name of it. Phenol. PHENETOLE. Phenol. If we have two methyl groups on benzene, what do we call it as? Xylene. Right? If you have a CH3 group and OH, then it is called cresol. Ortho position, that's why it is called orthocresol. Here also I call it as orthoxylene. Right? Now, if we have OH group and aldehyde group, then it is called salicylaldehyde. If we have OH group and carboxylic acid group, COH group, salicylic acid. So we are talking about salicylic acid. This is salicylaldehyde. Next. If you have COOH group and here acetyl group, OCOCH3, then it is called acetyl salicylate, right? Acetyl salicylate, also called as aspirin. One more thing is there, sir. Oil of wintergreen, methyl salicylate, oil of wintergreen. Methyl salicylate. This one. On benzene ring, if instead of this position, if it is attacking over carboxylic acid, so if remains this phenol group as it is, and this converts into double bond O methyl. So this is called methyl salicylate. Also called as oil of wintergreen. What is oil of mirbane? Oil of mirbane, nitrobenzene. Oil of bitter almonds, benzaldehyde. Also called as oil of bitter almonds. Right. So another one is this cellol. Phenyl salicylate, cellol. Not solar. Cellol structure. Phenyl salicylate. See this? On benzene ring, if you have OH group, here it is C double bond O instead of methyl group, if I have phenyl group. This is called methyl salicylate. Then it is called phenyl salicylate. Phenyl salicylate is also called as cellol. Phenyl salicylate, also called as cellol. Right? Now come back to the salicylic acid, sir. So first I am taking salicylic acid. Any questions regarding this up to here? Right? Now coming to salicylic acid. So I am taking salicylic acid. Allowed to react with NaOH and calcium oxide. What is this one, sir? NaOH in presence of calcium oxide followed by heating. Decarboxylation. So during decarboxylation, what happened? CO2 is gone, and then what you will get? Phenol. Correct? Now? As it is basic medium, you will get sodium phenoxide. Correct or not? You will get O minus Na plus, sodium phenoxide. Now this on acidification and in presence of acid, then what you will get? Converts into phenol. Right? Any questions? Next one, sir. From halobenzene, fourth reaction, preparation of phenols from halobenzene. Halogens, if they are present on benzene, we cannot replace them easily by using OH group. Why? We call it as nucleophilic substitution. Right? Because of partial double bond character. So on benzene ring, if you have any halogen, either fluorine, chlorine, bromine, iodine, they involve in this lone pair involve in resonance. So and hence you will get partial double bond character. right? Therefore, nucleophilic substitution is not favorable. Any questions are in this? Because of the double bond character, right? That is the reason we need to provide high temperature and pressure. We call that process as Dow's process. So chlorobenzene with 2 moles of NaOH at 350 degrees centigrade and a pressure of around 300 atmosphere. Then NaCl is lost, H2O is lost. So then the product will be again sodium phenoxide, correct or not? As we are providing basic medium, you will get sodium phenoxide. Now it is allowed to react with H3O plus. I am adding HCl. On adding HCl, what happened? NaCl is lost, leads to formation of phenol. Next, from cumene, very, very important reactions are this is. Preparation of phenol from cumene. What is cumene? Isopropyl benzene is called as cumene. This is called as cumene. Allowed to react with oxygen on heating. What happens, sir, here? Benzylic hydrogen. Oxygen get substituted at benzylic hydrogen. Means here this hydrogen. So leads to the production of, this is the intermediate. Here you will have OOH. Cumene hydrogen peroxide. Cumene hydroperoxide. Now, this on heating with sulfuric acid. At around 50 to 90 degrees centigrade. Then bond will cleavage here. Right? There is some sort of rearrangement. Observe this. This undergoes rearrangement like this. I am writing this like this. OOH. Right? So I am doing rearrangement. 1 minute. Let me write that ring also. I am doing that rearrangement. Make this bond shift here. Make this bond to shift here. Right? I am shifting this bond here. And I am shifting this bond here. What do you get now? What happened? Acetone plus phenol. Very, very important reaction. Preparation of phenol from cumene.
Sir.
Yes, sir.
Sir, why that replacement is happening, sir?
Where? Benzylic hydrogen, man. Where charge, positive charge is more stable. Right? I am writing this hydrogen peroxide in this way. HOOH. I am ionizing this as H plus OOH minus. Correct? Huh? Response,
Okay,
sir.
sir. Okay, sir.
Now, over this position, if I remove H as H plus, whether it will be very much stable or not. If
Yes,
I
sir.
remove H plus, what happens? It is tertiary carbocation as well as benzyl carbocation. So extremely stable. So from here H can go out as H plus. Correct? Huh? Respond.
Yes,
And
sir.
at the same time, at this position, anion is also stable to some extent. Why? Because it can involve in resonance. You can get double bond character over this bond. So both are equally possible. So what I am doing is I am doing some rearrangement here. I am doing some rearrangement, or I can do radical mechanism also. Can I do radical mechanism? I can make it as H radical, OH radical. Can I do it? No. Carbocations and radicals almost have similar stability order. Respond. So I am bringing that H radical here and this OH radical here. There is bond formation here and H2 gone. Possible or not? Say something, sir. Acceptable?
Yes, sir.
Right. So I can do this by using radical mechanism, or I can form through ionic mechanism. So this is formation of phenol. One more reaction, sir. Benzene when allowed to react with Fenton's reagent. Benzene with Fenton's reagent. What is Fenton's reagent? Yesterday also we have seen. What is Fenton's reagent, sir? Fe plus 2CO, Fe plus 2 salt in presence of hydrogen peroxide is called Fenton's reagent. Then it leads to formation of phenol. If a phenol is allowed to react with very strong oxidizing agent, then, for example, H2CrO4, chromic acid, or K2Cr2O7, or K2Cr2O4, or K2S2O8, and if it is allowed to react with K2S2O8, then what you will get? ELBS oxidation. Very, very important. ELB apostrophe. ELBS reaction, ELBS oxidation. Then it will form phenol. Instead of this, if it is allowed to get oxidized with strong oxidizing agent like H2CrO4, H2CrO4, then or K2CrO4, then what you will get? Phenol. If it is allowed to react with oxygen in presence of vanadium pentoxide, V2O5, malic anhydride. Malic anhydride. Right? Hello, sir. Hello. Yes, sir. Yes, sir. Then, sir. Regarding the right. So from benzene also by using Fenton's reagent, we can form. This is called Fenton's reagent, right? We can get phenol. Right? So these are different methods of preparation of phenols. So all methods of preparation of phenols are over. Next, regarding physical properties, sir. Whether phenol is acidic or not. So, what is pKa of phenol? Phenol, pKa.
Sir, 4.1 something, sir.
I think we have seen these exact values in electronic effects chapter. Electronic effects. In which I will go to phenol. 9.95. Right? I think you are talking about benzoic acid. On
Yes,
benzene,
sir.
if you have COOH group, benzoic acid.
Yes, sir. Yes, sir.
pKa value is approximately 4.2. This is approximately 4.2. Lower the pKa value, stronger the acid is. Lower the pKa, higher the Ka, stronger the acid is. Correct, sir? Presence of minus I and minus M groups. They will enhance acidic nature of acids. For example, if you have NO2 group on phenol, if we have 3 NO2 groups, then it becomes very strong acid, correct? What we call this acid as? Picric acid, very strong acid. It is even stronger acid than benzoic acid. So pKa value of picric acid is, let me check once, 1.02. Observe the pKa value, sir. Is it very strong acid or not? Its pKa value is 1.02, means very strong acid. Far strong acid than benzoic acid, right? So phenol is acidic in nature, right? So now I'm coming to physical properties. It is a colorless solid. And one more thing, when you take a beaker of means a phenol compound, it seems to be colorless solid. Before using it, I need to heat it. If I heat, it will convert into liquid. Once it converts into liquid, it will never convert back to solid, right? So we need to convert into crystallization. We have to do crystallization very carefully. When you open that vessel, because of atmospheric oxygen, phenol can convert into quinone. With the quinone, other phenol molecules will form hydrogen bonding and impart pink coloration, right? Phenol in atmospheric oxygen converts into quinone. With the quinone, other phenol molecules will involve in hydrogen bonding. Will you understand like this? Quinone, phenol molecule showing hydrogen bonding, right? Because of this, it impart pink coloration. Just a moment, let me show that also. No, I cannot. Here I can write, I think so. No, I cannot write also. Huh? See this? Phenol turns to pinkish or brownish color on exposure to air due to slow oxidation, leading to the formation of quinone and quinoquinone. I want that structure, but it is showing. Oh, sorry, I am typing there. Is due
Sir.
to. Yes, sir.
Sir, your screen is not clearly visible, sir.
Why it is not visible? Here. Okay, okay. This screen is not visible, huh? Okay. I think this screen I can't share. Hmm? This is phenolphthalein. How can I go back? Shit. I will close this. Okay, leave it, man. Pink color is due to compound formation like this, right? So this will impart this structure will impart pink coloration to phenol. Right? So when phenol got exposed to atmospheric oxygen, you will get pink coloration due to formation of hydroquinone or phenohydrone. Now it is colorless, solid, but once you heat it or once you melt it, it converts into liquid and it will not convert back to solid again. So colorless solid having a melting point approximately 42 degrees centigrade and a boiling point approximately 182 degrees centigrade. It develops pink color. Develops color. Either you can see that color as either pink or red towards radiant on exposure to air. Reason? Due to oxidation. Slightly soluble in water, not readily soluble in water due to presence of benzene. Due to presence of OH group, it can form hydrogen bonding to some extent. So sparingly soluble in water. So slightly soluble in water due to hydrogen bonding. But readily soluble in organic solvents. Like diethyl ether or benzene or carbon tetrachloride, etc. So this is about physical properties. Now regarding chemical properties. first chemical properties because of its acidic character. Means if I am able to replace H plus by using some other reagent, they are all chemical properties because of acidic hydrogen. So that is the first chemical property due to acidic nature. Means can I allow phenol to react with metals like sodium and so on? I am taking phenol, allowed to react with metals, or can I allow it to react with NaOH? With NaOH, what you will get? What you will get, sir? O minus Na plus, and you will get H2 gas. Correct? Huh? Then with the CH3COCl, acetyl chloride, in presence of pyridine. Now what happened? Acetyl chloride. What happens, sir, here? Can write phenol like this, right? Having lone pair of electrons. I am writing phenol with lone pair of electrons, and I am taking acetyl chloride like this, CH3, C double bond O, Cl. Can I make this to donate lone pair of electrons here? Sir, why you are not allowing oxygen to donate lone pair? Why you are donating only phenol to donate lone pair? This is acidic hydrogen, means what happened? The electron density over oxygen increases. Therefore, it is electron rich species. Now in C and O, oxygen is more electronegative. Therefore, carbon gets partial positive charge. Therefore, this electron rich site will donate electrons to carbon. So now what you will get? Can I write as O, C, O minus, CH3. Correct, sir? Of course, I have removed that H plus. Now this will come back making Cl2 leave. So what you got? PHO, C double bond O, CH3, and this H plus and Cl minus will form HCl. That HCl will get trapped by pyridine. Pyridine is base. So base will react with HCl to form pyridinium chloride. So the product is, what should be the product, sir, now? What should be the product? O, CO, CH3 plus pyridinium chloride. Response, sir. Any questions in it? Next, with acidic anhydride in presence of pyridine. Acidic anhydride means, can I write AC? AC means CH3CO twice O. Correct? Or CH3CO again CH3CO. This is AC. This is AC. O. So what we got as acidic anhydride. So I am writing it as AC2O, acidic anhydride in presence of pyridine. Now tell me what is the product. Again same. Phenol will donate one pair of electrons. This will go up, come back, and this will be removed. Right? So the product is, what is the product now? On benzene, OCOCH3, and this pyridine will react with acidic acid. Correct? So instead of Cl minus, I will have CH3COO minus. Response, sir. Any questions in it? Next, with the azomethane, CH2N2 with azomethane. Now from here, if I remove N2, what do you get? This carbon have empty orbital. I am writing CH2 N triple bond N. This is CH2N2, right? Or I will write like this, N double bond. Here also I will write double bond. Over this N I will write plus, over this N I will write minus. Okay, va? Now I am taking phenol, PHOH. I am making oxygen to donate lone pair of electrons. If it donate lone pair of electrons, what happens? This bond will shift over N. If that shifts over N, what you will get? PH, OH, single bond, CH2, bond N, double bond N minus. Now, nitrogen's positive charge got vanished and it will convert into lone pair now. Correct? And over this oxygen, you will get positive charge. Correct or not? Now, I am removing this H as H plus. What I am doing is, I am making this bond to shift back, and I am making this bond to shift back here, and I am migrating this H as H plus to move here. Now, what you will get? When this bond shifted, N2 gone. When this bond shifted over CH2, you will get CH2 minus. From here, H plus goes there. So, product will be. Can I write any soul is obtained? Any soul is obtained, and what is lost? N2 gas is lost. So, in all these cases, in phenol, which I am replacing? Hydrogen. Because of acidic hydrogen of H plus, all these reactions are shown. So that's why all these are because of acidic hydrogen. I am writing a note. Compared to phenol, phenoxide ion is more stable. Reason, sir? Compared to phenol, phenoxide ion is more stable because the phenoxide ion involved in resonance. I am writing double bond O, negative charge, bond, bond, again resonance. Double bond O, negative charge here. Again, different resonating structures I am writing. Right? That's why phenoxide ion is more stable. Next. Acylation reactions. Second reaction, sir. Acylation reaction. What is this reaction? What is second reaction? Is it acylation reaction or not? What about this one, acetic anhydride? This is also acylation? Response, sir. So I am repeating the same. So what they are saying is, with the acid halides, it forms phenolic esters. With acid halides, it forms phenolic ester. Right? We call this process acetylation. Over. So I am directly writing that reaction. Acetylation reaction. Phenol with acid chloride in presence of pyridine. What is the role of pyridine? To remove HCl. So you got here OCOCH3, and that pyridine will trap that HCl to form. Response, sir, correct or not? pyridinium chloride. Now, same phenol with benzoyl chloride, means PHCOCl, benzoyl chloride, in presence of NaOH. Now tells the product. Again, what happened? From this Cl, HCl is lost. That HCl will react with NaOH to form NaCl plus H2O. So product will be, on benzene, you will have O, CO, phenyl. What we call it as? What we call it as? Phenyl benzoate. Hey, is it Celal? With same reaction with the salicylic acid. If you have COH group also, then it is called Celal. Response, sir. Correct or not? Benzoyl salicylate. Then it is called Celal. If you have one more COH group here, then it is Celal. Right? Now it is phenyl benzoate. Phenyl benzoate ester plus NaOH will combine with HCl to form NaCl plus H2. Any questions in it? Next, with the SO2Cl2, I think it is sulfonyl chloride. Phenol allowed to react with SO2Cl in presence of pyridine. Now tell the product, sir. Again remove HCl. Again remove HCl, sir. From here H, from here Cl. So product is, respond. What will the product? Here already O is there. This is SO2. Again benzene ring. That HCl is trapped by pyridine again. So all these are like acylation. I call this as sulfonation. Right? Next heading, sir. Electrophilic aromatic substitution reactions. Nucleophilic substitution reactions we have seen in case of haloarenes. Right? Reaction occurs via two mechanisms: addition, elimination, or elimination, addition. Correct or not? These are all electrophilic substitution reactions, means they have to attack on benzene ring. Correct? So first, I am taking phenol. I will write this at the center. This on reaction with concentrated HNO3 in presence of concentrated H2SO4. What is this? Nitration? Response, sir. During nitration, HNO3 act as base, H2SO4 act as acid. Then what is the reagent? Electrophile is NO2 plus. Now NO2 plus will go and attack on benzene ring. What type of group OH is? Ortho para directing. So that NO2 group goes to either ortho position or para position. Right? Respond. Now, here the product will be OH group, and you will have NO2 group either at ortho position or at para position. If I provide sufficient supply of nitration, then you will get all ortho positions on nitro position, para positions are occupied with nitro group. Respond. So you will get picric acid. Acceptable or not? Now, at the same time, can I say concentrated HNO3 is a very good oxidizing agent? This oxidizing agent can oxidize phenol. If a phenol oxidized by oxidizing agent, what it will form? Phenol. So I always get phenol as a product here. Sir. Yes, sir. Okay. We will ask the EDP to share to all the students. And we will request in class. To EDP, sir. Inform ABM, sir, also. He will take care. Right. So this is quinone. Now, as this is very strong oxidizing agent, we generally expect picric acid as a product, as major product. But here, which will be major product? Quinone will be the major product. Because this is a good oxidizing agent. So along with nitration, oxidation also happens. So oxidation becomes major product than nitration product. If you want nitration as major product, then I have to use N2O5. N2O5 will act as NO2 plus and NO3 minus. Now NO2 plus will go and attack over benzene. Is it clear? If you take 20% nitric acid, HNO3, right? See here, because of presence of electron donating group, same thing. If it is NH2 here, then what happens? You will get artho nitro, meta nitro, para nitro also. We discussed that point. If in case of aniline on reaction with the nitration, during nitration of aniline, you will get artho, meta, para. Generally, we expect para as major, right? And artho as minor, correct? But meta, we will think meta is not at all possible, but meta is possible. Artho is highest, around 51%, 49%, and artho will be around 2%. Is it clear? Any questions? Right. Now, phenol with 20% HNO3. Now you will get orthonitrophenol and paranitrophenol. Now tell me, among these two, which is major? Reason: intramolecular hydrogen bonding. Because of intramolecular hydrogen bonding, it becomes stable. That's why ortho becomes major. Generally, in all cases, we will think para as major. Because of hydrogen bonding, here ortho becomes major product. Next, with bromine in presence of H2O. This is very, very, very important reaction, sir. Br2 in presence of any polar protic solvent. Right? Bromine in presence of polar protic solvent. If I take H2O, you will get 2,4,6 tribromophenol, white color precipitate. They asked this question in JEE as well as mains advanced NEET many times. White precipitate. 2,4,6 trinitrophenol. Very, very important reaction. Now, same bromine, instead of water, if I take carbon disulfide or CCl4, CS2 or bromine in presence of CCl4. Br2 in presence of CCl4. Alkenes, we discussed this. Alkenes in presence of Br2 CCl4. three-membered cyclic transition state. Br plus will go and attack first. Now here Br plus is generated. Br plus can act as electrophile. Now it will show electrophilic substitution, and OH is ortho para directing. So you will have Br plus at ortho position or para position. Observe. If it is water, 2,4,6 tribromophenol. If it is CCl4 or CCS2, right? Aprotic solvent. Then what you will get? Or non-polar solvent. Then the product will be ortho bromo or para bromophenol. Now which is major? Reason it cannot form stable hydrogen bonding. So only repulsive interactions are dominative. So major product will be para. Any questions? Next one. With the sulfuric acid. With the H2SO4 at 25 degrees centigrade. And what happened? Sulfonation. Only you have taken H2SO4. So it will form sulfonation product. HSO4 will go and attack it either ortho position or para position. So product will be SO3H either at ortho position or at para position. Now tell me which is major. Which is major, sir? Can I write like this? This is OH, S double bond O, double bond O, OH, SO3H. Is there any possibility for intramolecular hydrogen bonding? Right? If intramolecular hydrogen bonding is possible, then which becomes major? Ortho. So ortho will be major. If there is no such hydrogen bonding possible, then para will be major. Next. H2SO4 at 100 degrees centigrade. Reacts with the H2SO4 at 100 degrees centigrade. Now, see, on heating, if I heat, ortho also rearranges to para. Now tell me here which is major. Para will be major. So I will do one thing. I will change its position so that you will not get confused. It will be a H2SO4 at 100 degrees centigrade. Now here also I will get two products. Yes, sir. OH, SO3H at para. Again OH, SO3H at ortho. Now para becomes major. Means on heating, ortho also will rearrange to para. That's why para becomes major at higher temperatures. Next, with NaNO2, HNO2. NaNO2 in presence of HCl or HNO2. What is this? Hey, is there primary amine to form diazonium salt? Is there primary amine? If it is primary amine, then it will convert into diazonium. Now what happened? It will produce NaNO2 and HCl or HNO2. What it will do? It will produce NO gas. Now NO act as electrophile and it will go and attack it either ortho position or para position. If NO go and attack it ortho and para position or para position, so what should be? You will have NO group yet. Response, sir. Yes or no? Now it can show tautomerism. This bond will shift, this bond will shift, this bond will shift, and this bond will shift, and that H will come here. So what you will get? It will tautomerizes to double bond O, double bond N, OH. Correct? Nitrosophenol, or it will convert into hydroxy, what do we call oxime, na? Phenol, phenoxide. Right? So these are the products. So most of the electrophilic substitution reactions are done. Then nucleophilic substitution reactions. Completed. Okay. It will give a reminder also. Huh? Right, sir. I will stop the discussion. Join in the next link. Online.
Okay, sir.
On, sir. So
Yes,
I am
sir.
closing the session. Join in the next link, sir.
Thank you, sir.
How to stop this? Okay, how to go here? How to end, sir? It is showing only rejoin. Here. Okay, stop sharing. End the meeting. Ended up. Who knows? Attendance 72 people. Who will take attendance? Array, offline students, you tell me, sir. If you find anyone offline here, you tell me. Okay. Then Charudishna, Chandresh. Who? Ahmad Adila. Okay. And next. Yes, sir. Chandresh, where? Okay. Then Dilip, Durai Aditya. Dilip, okay. Deepan Raj, okay. Yeshanmayi, Gayatri, Hariharan, Harshada, Haswantan, Hemarudra, Johnson Davies. Who? First one. Haswantan, okay. Haswantan, Hemarudra, okay. Jagadish R, Joel Blesson. Joel, okay. Joel Ignish Ray or Joel Blesson? Okay. Joel Ignish Ray, Madan E, Medhavarshini. Madan E present, Where? Yes, sir. Medharshini also present, okay. Mithil Bharat, okay. Muhammad Umar Farooq, Mohit Saran, Mukil Vamanan, Mukil, okay. Ajay Khanna, not there, na? Yan Pranav, Nagadanoj, Netesh Kumar, Netra, Neele Jayam, Jay Krish. Jay Krish present or not? No, PSV Abhinav, Bhavita, Deshna, then Ramakrishna also present. Yes, sir. Ritish Nataraj, Sivarval Raj, present. Yeah. Sachin, Sai Visagan, Sektivel Pandi, Samant, Sektivel Pandi present. Okay. Then Sanjeev Kumar, Sankar Narayana D, Saravana Perumal,